Greetings. I'm Dr. Jason Ozuko from the Psychology Department at SUNY Geneseo, and welcome to the next video in our online PsychoPy course. Today we're going to be looking at some of the advanced ways you can load and shuffle stimuli for your experiment. And this video is going to directly build off of the prior video where we built a Stroop experiment in PsychoPy. So as a quick refresher, in our previous experiment, we created a stimulus file that contained words and colors, as well as correct keys and conditions. Our experiment itself was pretty simple. We had a welcome screen, a goodbye screen, and then a trial loop. And on the trials, Stroop words were shown for up to 2 seconds, and participants could make a keyboard response, which would end the trial early. And the keyboard was scored in terms of its accuracy. We also recorded its reaction time. Now, one of the things we noted is that the condition file that we used to control our loop essentially was able to randomize our stimuli, but could only randomize one entire row at a time. And I said to you in the prior video, what if you wanted to have a list of words and a list of colors, and you wanted to randomize those separately? How could you do that? And so we're going to be looking at how you do that today. And we're actually going to get rid of this condition file, this set of stimuli, and we're going to start with a much simpler list. And we're going to have PsychoPy through code determine whether trials are congruent or incongruent, and also what the correct keys are. So I'm actually going to create a whole new stimulus file here, and I will call this simple Stroop stimuli. And in this new sheet, all we're going to have are words and colors. So words, red, green, blue, and yellow, and colors, red, green, blue, and yellow. And what I'm going to do is load in the words, load in the colors, but shuffle these items separately, and I'm going to construct myself congruent and incongruent trials. So let's see how that actually works in PsychoPy. So first things first, in the trials that we had before, we're actually going to get rid of our condition file, and we'll come back and deal with the rest of what we need to change here later. But for now, just understand that we're no longer going to have a condition file in our loop, because instead we're going to load all of our stimuli ahead of time. And so we're going to use a loader loop. I'm going to create a new routine, and I will call this the stimulus loader. And I'm going to insert it before the welcome screen, and I'm going to put a new loop around that stimulus loader. And the conditions for this loop is going to be our new condition file. So simple Stroop stimuli. This only needs to repeat once, and this isn't trials. I uncheck this because in actuality, what we're going to do is have some custom code that goes through and grabs all the variables from this list, and then we're going to use custom code to create our own arrangement of the stimuli. And so this loader loop isn't a set of trials that we want to log, because the participant isn't even going to know this loop exists. We're not going to put even a text component on this loop. So it will simply occur in the background before subjects even begin the experiment. So this isn't trials. And in fact, we can even switch this to sequential selection if we'd like, because we might want to pull items out of our file in order before we ourselves randomize things. You can leave this as random. There's no harm in doing that. I'm going to have mine as sequential just so you can see that we're going to be pulling things out of this list in order, and then we ourselves are going to figure out how we want to shuffle things. So I'm going to save this. Note that it says no parameter set found in my simple Stroop stimuli. It's because I hadn't actually saved my Excel sheet with the word and color variables in before I selected it. Now that I've saved it though, I'm going to go and reselect my stimuli, and you'll see we have 4 conditions with 2 parameters. It's showing up in red because I have the variables word and color elsewhere in my experiment, but it's fine to have the same variable names in multiple places, just as long as you know that you could potentially get conflicts by doing so. But long story short, we're not going to have to worry about that with the way we're doing things. Okay. Oh, and I'm actually going to rename this to be our loader loop rather than trials. So next, we're going to go into our stimulus loader, and we're going to add some custom code. So under the custom area of your components, scroll down and select code. And we will call this the loader code. For code objects in PsychoPy, you can insert Python code on the left and JavaScript code on the right. When you run experiments locally, the code on the left is what is run. And when you run things online, the code on the right is what is run. So by default, on the left here, everything you type in here has to be in Python. Whatever you type is automatically translated on the right into JavaScript. So if I had a variable, A is a string, B is 25, and C is equal to A plus space plus string of B. So note that I'm typing in some very basic Python code here. So if you're completely unfamiliar with coding, I definitely recommend looking up some really basic tutorials on Python coding and what variables are and what if statements are and loops. I'll be trying to explain things as we go, but to be totally honest, this isn't a video meant to explain how Python coding works. It's meant to explain how PsychoPy works. So I'm going to assume a little bit of basic understanding of variables and coding. But nonetheless, on the left here, I'm creating two variables. A is going to be equal to a string that just says this is a string. B is equal to the value of 25. C is a new string that first takes A, then adds a space, and then adds the number 25, but in string form. And so you can see that this is the Python version of that code. And here's the JavaScript version. It's very similar, but there's semicolons at the end of each line. And rather than using the function str to convert B into a string, it uses the class function toString, which is part of the integer class in JavaScript. So here's the Python. This stuff gets executed locally. Here's the JavaScript. This stuff gets executed when you run stuff online. And by default, Python gets converted to JavaScript. Now you can switch things to Python only. You can switch things to JavaScript only. And you can switch things to both, which basically means manually you're going to enter things. So D equals this is a second string. Note that when you're in the both format, you can change things in Python and it won't automatically update in the JavaScript side. It's up to you to maintain equivalent code in the JavaScript side. This is not a string. Now, if I did this, note that now the variable D is equal to something different in my local version versus my online. So whenever you are coding in both, you really have to make sure that you're maintaining equivalent code. It is possible to create different versions of the experiment if you don't keep the code equivalent in the local versus the online version. Now, why would you ever want to use this? Why wouldn't you just leave it as automatic? Well, as we will see, the automatic translation from Python to JavaScript is quite good, but it doesn't always get everything perfect. And so there are going to be things or circumstances where we need to go in and manually change what's over here. And you can't change this at all. I'm trying to type, but it won't type. You can't change this when it's on automatic. So you'll have to go to both, and then you'll have to maintain things in both versions. Another circumstance that might arise where you want to code in both, or maybe even you just want to abandon Python, for instance, is if you are just designing an experiment to only run online, then you only really care about getting the JavaScript side working. The Python doesn't matter, and you might even turn the Python side off. Or vice versa. If you're only coding things locally, you just want to make sure this works. You might leave it on automatic and not care if this would actually run or not or create errors, and you just try and get this correct. I prefer to leave it as either automatic or both. I don't like programming only in JavaScript or only in Python because, you know, you never know. Maybe you design an experiment to be run locally, but then something happens and you decide you need to run it online. It's nice to have at least something in JavaScript to get started with. And vice versa. Maybe you just start coding it as an online-only experiment, down the line decide you want to run it locally, it's nice that to have the Python there. So I like to leave it as automatic or both, but you can do whatever you prefer. Now, the other thing to note about code components is that you have these different tabs where you can insert code, and this will determine where it actually runs. So the first tab before the experiment means that whatever you type in here is going to be executed before almost any other code in the experiment is executed. So here's where you want to put really basic universal things that you might want to reference in the rest of your experiment. For instance, if you have a custom function that you want to include here in your experiment so that you can access it in other parts of your experiment, you might want to include it in the Before Experiment tab. Begin Experiment is where the experiment has been instantiated. PsychoPy has done its basic startup, but it hasn't actually started anything on the timeline. So you can enter some code here, and it will essentially be the first thing that's executed before the timeline begins. This tab here, Begin Routine, will execute at the beginning of, in this case, the stimulus loader routine, because that's where this code loader is going to be. We have each frame, which will execute on each frame of the stimulus loader. So as long as the stimulus loader is on the screen, this code will continually execute. So this is handy when you want to, for instance, maybe you have a text object that's shown for a second, and maybe you want to have a sound that plays after 500 milliseconds. In the each frame area, you could continually check how much time has passed since the routine began, and when 500 milliseconds have passed, you could then execute a command to play the sound. So that's one example of what you might want to use the each frame area for. End routine is code that gets called when this routine ends. So begin routine is when stimulus loader begins, end routine is when it ends. And then similarly, end experiment is at the very end of the experiment after everything else has finished. So there's a lot of flexibility here with when you want to have code executed and what you want it to do. For us, I'm going to delete this sample code that I was just typing in there. We're going to execute some code on the stimulus loader every single time the routine begins. And let me just leave this as blank for a moment. And let's go back in here and see what our loop is doing so we can get a better sense of what we actually want to do in our code. So we have the simple Stroop stimuli sheet that we're loading in. And we're going to load in 4 stimuli. On each iteration of this loop, the variables word and color are going to take a value from one of these rows. On the first iteration, word will be equal to red and color will be equal to red in lowercase. On the second iteration, green and green, third iteration, blue and blue, and then yellow and yellow. I have it in sequential mode. If it was random, it would just go through all 4 items, but just in a random order. What we can do is we can save word and color at the beginning of each iteration of this loop into a list ourselves. And we could, in fact, have 2 lists. We could have a list of words and a list of colors. And then after the routine is over, we could shuffle those items. So that's how we're going to load in these items and shuffle them ourselves. So let's go back into our loader here. And at the beginning of the routine, actually at the beginning of the experiment, let's make 2 empty lists. We'll have word list and we will have color list. So these are empty lists to hold our stimuli. Now note that the JavaScript version has created equivalent code, so this will run online. The JavaScript doesn't translate comments over or spacing, but it's not really essential. This is just a comment for our own sake. So at the beginning of the experiment, we make 2 empty lists. Now, every time the routine runs, we're going to save word and color. So to save word, we're going to add word to the word list. So word list dot append word. Similarly, to save the color, we're going to save color. And so save the current word and color on each iteration of the loop. So this will save the word and color. And essentially, that's all we need to do in order to load our 4 words and our 4 colors. So we're going to insert one more routine now, and we're going to call this the stimulus shuffler. And this will occur after our loader loop. And here we're going to insert one more section of code called the shuffler. And once again, we're going to go to the beginning of the routine. Careful, you can accidentally put things at the beginning of the experiment. And that would mean the code here would try to execute at the very beginning of the timeline. But the code we're about to write is going to look at the lists that were just loaded here. So it has to occur after the loop. So we want this to be at the beginning of the stimulus shuffler routine. And we're just going to right now print out the word list and print out the color list just so we can see what it is that we've loaded in. So this is just for our own purposes. Note that once again, the JavaScript side is coming up with equivalent code. And in Python, print commands will print information out to the console area over here. But in JavaScript, you have to use console.log, and that will actually print information out to the debug developer console that you can find in your web browser. So it's equivalent, but it's not identical. And that's the name of the game in converting things from Python to JavaScript. I'm going to go in here, and I'm going to turn my screen onto not full screen. And I'm going to use 1280 by 720 for my resolution. And I'm going to click OK. And that's just so that we can see the output in the debug area while we're running the experiments. We don't have to actually quit to see it. So now our experiment begins. Notice we've made it to the welcome screen. And look what we've got printed out here. Red, green, blue, yellow, red, green, blue, yellow. We just printed out the word list and the color list. Great. However, we need to do something with those words and colors. We need those items to show up as trials in our Stroop trial. So let's start really basic and just say, what can we do with the list that we've got? Well, if we just showed the words and colors as they are in our Stroop trials, we would always show red and red, green and green, blue and blue, and yellow. But we said that in Stroop experiments, you sometimes want the word and color to match, and you sometimes want them to mismatch. So how could we rearrange the words and colors so that they don't always match? Well, there is a handy function in Python called shuffle. And we can use shuffle in order to shuffle our lists. Now note that in JavaScript, shuffle is also being called. We will eventually run this experiment online, and I'm going to show you how shuffle right now won't actually work in JavaScript. However, there is a fix we can implement that will make it work. So right now, we're going to just develop this experiment all locally, and we'll see later how it breaks when it goes online and what you can do to fix those breaks. So let's rerun our experiment and see what shuffle did. And again, we're not going to get to our Stroop trials yet. We're just going to see the output in our debug area. So our experiment runs, and I realized I took out the print statement. Let me come in here and print word list and print color list. All right, so the lists were shuffled, but I didn't actually go in and output them to the debug area, so we didn't see anything here. All right, so we're going to run this one more time. And this time, we will see blue, yellow, green, red, yellow, blue. Perfect. So let's go and arrange things such that our new stimuli in our new order are shown on our trials. I'm just going to add a few comments here. It's always very good habit to comment your code as much as possible. First of all, so that you can keep track in your own mind what your code is supposed to be doing, because a lot of times you design your code and you write it, and there might be a little error or bug in the code, and it's supposed to do X, but it does Y instead. If you're always commenting what each section of the code should do, then you know what should be happening, and it will help you keep track of when you've actually made a mistake in the coding. And the second reason to code things or to comment things a lot is for you or anyone else who comes to look at the code in future, it's a lot easier for people to figure out what is happening in your code if you have descriptive comments. So, and it doesn't take much to comment things. So shuffle the stimuli lists to create a new order. We'll have debug output or checking. So very simple comments like that go a long way. All right, on to our Stroop trial. So what did we want to have happen on our Stroop trial? Well, on our Stroop trial, we were showing a variable called word, and word was shown in a color. Well, we are no longer using an Excel sheet in our Stroop loop. So we actually have to come up with variables ourselves. So here's one idea we could use. We have a word list, and the word list looks something like this. I'm just going to grab these for demonstration purposes. So this is our word list, and this is our color list. Here's an idea of what we could do in our Stroop trials. What if we had a counter that said current item, and it started at 0? So it started at the first item in each loop, or in each array. And on the very first trial, we said, look at word list 0 and color list 0, and that will be your word, and that will be your color. Well, in that case, on the first trial, we would see the word blue in green ink. Then, on our next trial, we could increment this to 1, and we could increment these to 1, and now we could load the word yellow in red ink. And then on the next trial, we could increment this again, and these would therefore be incremented, and now we'd grab the word green in yellow. We could essentially iterate our way through our word list and color list ourselves if we had a counter that could keep track of how many items we had seen so far. So let's go ahead and build that. So in our Stroop trial, we're actually going to add a little bit of code. And we're going to say this is the Stroop code. So at the beginning of the experiment, let's create a variable called current item, and we'll set it equal to -1, which is just, our loop hasn't even started yet. So this is an item counter for our Stroop task. Now, what we want to have happen is at the beginning of each iteration of the loop, we want our current item to increase by 1. So that means that on our very first Stroop trial, this will increment by 1, and it will become 0, our first value. So at the beginning of our Stroop trial, we want current item to be equal to current item plus 1. Another way to write this, a quicker way, is plus equals 1. This means current item is equal to itself plus whatever's here. That's what the plus equal is. So this increments the item counter by 1. Now, what we can do is we can create those variables word and color that our stimulus, that our Stroop trial depends on. So word can be equal to word list of the current item, and color can be equal to the color list of the current item. And so on our first trial, this will be word list 0 and color list 0. So the first word and the first color. On our second trial, this will increment again, and this will be word list 1 and color list 1. And so the next item in the list and the next item. And so our word and color variable are going to be updated as we go through this list. Color variables. So at this stage, we have now loaded in 4 words, 4 colors. We've shuffled the list independently. And now, as we cycle through our Stroop trials, we will get a random word paired with a random color. So there's yellow in yellow. Oh, and our experiment actually crashed because we have a remnant from our Excel sheet when we had a correct key. So in our Stroop experiment before, we had the variable correct key, which was identifying what the correct answer is. We could turn this off, but instead, why don't we leave it on and actually add in the correct key variable? So in our code over here, we're creating the word, we're creating the color. Why don't we determine what the correct key is? So the correct key is equal to the first letter of the color of the ink, right? If the color is red, you press R. If it's green, you press G. If it's blue, you press B. And Y, you press, or yellow, you press Y. So we can actually, because we've created a color variable, we can use that variable and just grab the very first item, the very first character from that string. And this code here is going to actually do that. Again, in JavaScript, this might not work, but we'll fix it if it doesn't. Okay, if we run our experiment now, we not only have assigned word and color, but we've also assigned correct key depending on what the color is. So we didn't have to hard code it into our stimulus sheet. So there we go. So if you were paying attention, there were actually two bugs that occurred. One is that our experiment crashed, and we'll deal with that. The other is that on the first trial, we were supposed to see blue in green ink, but we instead saw yellow in yellow ink. So we saw this. Why was that occurring? Well, the reason it was occurring is because the order in which we have our objects in our routine. So in our shuffler, in our loader, we are loading up variables word and color. By the time we get to our Stroop trial, the last item that we had loaded was yellow in yellow ink. So word, right now, the variable word is equal to yellow and color is equal to yellow. On our first Stroop trial, we set the variables word and color. However, we don't do that until after our stimulus is drawn to the screen. If you recall, in terms of timing, in terms of how PsychoPy executes things, it executes things in order on the timeline, but then within a routine, it executes objects one after the other. So there was a little bug in our code. It was subtle, but if you're paying attention, it was there, in that we were assigning variables word and color, but we weren't doing that until after the item was drawn to the screen. So the first item that we got was yellow in yellow ink. Let me show you this again. So we're going to execute this, and let's see this bug in action, because again, it's subtle, but it's a good lesson on paying attention to where you put your code and that timing matters. Okay, so if everything were working right, we should see on our first trial red and blue ink, green and red, yellow and green, and blue and yellow. What we're going to see is yellow, yellow, and then red, blue, and then green, green, red, and so on. So yellow and yellow, and then next we have red and blue ink, then green and red ink, then yellow and green. I mean, you can see the value of printing out your variables here because it helps you detect errors while you're actually running your experiment. So how do we fix this? So what we think is supposed to happen is that we first assign the variable word to be equal to the first item of the word list, and then that updates our text object. Well, if we want that to happen, this code has to be the first thing that gets executed on this routine. So this is a really good lesson. If you're using code in order to update your variables, make sure that your code is the first thing that gets executed in a routine. And now if we were to run our experiment, you'll see that this problem has fixed itself. We'll run, and let's see what order things should appear in. So we should see yellow and red, green and green, red and yellow, and blue and blue. Let's see. Yellow and red, green and green's next, red and yellow's next, and then blue and blue is next. Go. And then our experiment, of course, crashes because there's one other bug we haven't fixed yet. Let's try to figure out what this bug is. So we're getting an error on the line where we try to assign a word from our word list, and it says list index is out of range. What it's talking about is that current item is beyond the number of items we have in our word list. So our list index current item is out of range. That's what that means. If we think about what happened, we just finished seeing all 4 trials. The loop should end at that point. But if we look in here, the number of repetitions is set to 5. Each repetition is one cycle through our list. Because we only have 4 items, we can't cycle through 5 times. So number of repetitions has to be 4. One way we could fix this with code, actually, is in our stimulus shuffler, we could create another variable called list length, and we could have it be equal to the length of our word list. And if we did this, then in our Stroop trials, we could set the number of repetitions to list length, meaning that in future, if we make longer lists, we don't have to come in here and remember to update this from 4 to 5 to 6 to 7 to however many stimuli we end up having. The code will automatically look at the number of words we have, and it will make sure that we have that many Stroop trials. So I can click OK. Now if we run our experiment, everything will run correctly in the right order. We'll get through our Stroop trials without crashing the experiment, and we'll see the end screen. So here are the 4 trials. I'm going to skip through them a little quicker, and then you get your goodbye message. Now, there was one other thing that we had in our original list that we might actually want to translate here. So we've already not only grabbed the word and color, and we've programmatically figured out the correct key. We've programmatically figured out how many trials to show. But one other thing we were coding is whether the word and color matched. So essentially, whether we had congruent or incongruent trials. Because we're now shuffling things randomly, we can't put congruent or incongruent in our stimulus sheet, and we have to use some code to figure out if we have congruent or incongruent items. So how can we do that? Well, what we need to do is look at each item in our word list and compare it to each item in our color list and see if they are equal. If they are the same word, then we have a congruent trial. Otherwise, we have an incongruent trial. Let me just add a comment here. Determine the number of items we have. But then let's create our congruent, incongruent list. So we'll call this the con list, and it will be equal to nothing to begin with. And then what we want to do is iterate through each item in the word list. To do this, we're going to use a for loop. If you're unfamiliar with for loops, again, look them up quickly in Python and or JavaScript. But essentially, they are loops where you have a variable that can count. In this case, for instance, we want to have a variable that counts through the number of items that we have in our word list. So we want to look at the length of the word list, and we want to count starting at 0 all the way up to the end of that word list. So that's what this range is. So we have 4 words. So essentially, I will start being equal to 0. Then the loop will iterate again, and I will be equal to 1, then 2, then 3. Then it will end on the 4th item. One other thing to note, by the way, is that right now I haven't filled in my loop in Python, and so this is actually a syntax error in Python if I don't put anything here. If I put something in, it fixes, but without it, there's a syntax error. And note that on my JavaScript side, I get this syntax error message. This is actually really handy if you are coding in Python, because if you have made an error in your formatting, or you made a typo or something like that, PsychoPy will essentially alert you to that fact because it will tell you your Python has a syntax error. So it's actually pretty handy. Even if you are writing things entirely to be run locally, leave the JavaScript on because it will detect if you've made a typo for you and give you this handy little error message. But anyway, what we'd like to do is for each item, so for word list I, we want to check to see if it is equal to color list I. So if word list I is equal to color list I, then con list append congruent. So what we're saying is if the word list item is equal to the color list item, then add to the congruent list the value of congruent. Otherwise, add the value incongruent. Oops. And this will basically mean that we're going to build up a list that will detect if the word list and the color list are equivalent. So loop through the word and color list and determine which items are congruent / incongruent. Now, one thing to note is that our word items are in uppercase and our color items are in lowercase. And so if we compare them, red and red are actually not equal because one's uppercase and one's lowercase. So what we're going to do is we're going to take our color words and we're going to make them uppercase. And actually, sorry, upper is a function of a string, not a function to call on a string. And we're going to actually just do the same thing on the word list. I know that right now they are all in uppercase, but you never know. An RA down the line might enter a new word like this, and that would skip through and be detected as not equivalent in this case, even though they are. So let's just be extra safe, and let's make every word and every color uppercase before we compare them. And I'm going to go ahead and print out my congruency list so that I can see how this worked and whether this did work. I'm going to run my experiment now. And let's see how this works. And so in this case, we have 4 incongruent items. Since we only have 4 items, it's going to be really easy for items to be incongruent. In fact, you're going to get a lot more incongruent than congruent items in general with our current setup. But there you go. Green is congruent. The other 3 are incongruent. So we can successfully detect which items are congruent and which items are incongruent. Now, there's a variety of other things we could look at here. I just want to show you a couple more ideas for what you can actually do when you're loading your stimuli. And we're going to run this online in a moment. But one thing you could do is maybe you don't want just 4 items, but you want each of these words loaded 5 times and each of these colors loaded 5 times. Well, there's various ways to accomplish this, but how about during each iteration of the loader loop, rather than adding each word to the word list once, why don't we just add it 5 times? So you can simply copy the item 5 times like that. Another way to do this, or maybe a more elegant way, is to use a for loop. And in this case, we will add the word and color to the word and color list, and we'll do it 5 times. So both of those will lead to the exact same outcome, which is each word being added 5 times and each color being added 5 times. So now we'll get 5 times the words, 5 times the colors. We don't have to do anything else. The rest of our code functions just fine. Note that, again, because list length is determined programmatically, our code is going to automatically adapt to having a longer word list. We don't have to go in and change our Stroop trials to have more trials, because they will have the correct number of trials no matter what. Something else we can do as well. In our code here, we were coming up with a variable called word and a variable called color and a variable called correct key. We actually don't even need to do that. If you wanted, rather than using this variable word, we could just use this as our text that we're going to display. So you can use not just single variables, but multiple variables in a single statement when you're using the $sign to refer to code rather than raw text in a PsychoPy component. So we could get the same results of displaying the correct word by using the actual list item rather than a variable that we've constructed. And similarly, we can use this for our color rather than using the variable color. And so I'm just going to show you how to do that as well. Make sure you have the $sign. And we can even get rid of the correct key and use color instead. Go ahead and load. So in our data, that. And now because we've done that, we can get rid of all this code. We don't need that. It's extra steps. There are circumstances where you will want to assign variables like that, and there are circumstances where it's perfectly fine to just directly reference the lists. Where you would want to define a variable is if you have multiple lists that you want to read from in different loops, you could have some code that reads from the different lists and has the same end variables, so word and color. And you might be reading from list A for one loop and list B in another, but word and color are always the end variables. And then you can just reuse your routine that displays the items to the screen rather than having separate routines that reference separate lists. If you're not following what I'm saying here, don't worry about it. But just sort of for those who can follow, there are circumstances where you would want to have single variables. But I just wanted to show you it's possible to get rid of that. And if we run our experiment now, by the way, we're going to have a much longer experiment with more items. And so we load our items, and now look at all the items. Red, so blue, green, green, blue, red, red, yellow, yellow, green, red, etc., etc. And look, there are many incongruents, some congruents. But if we run our items blue, then we'll see green and then green. This will be congruent, yep, and then we'll see blue and yellow, and so on. So this is how you use code to load items from a list, to shuffle your lists independently, to build up your own stimulus lists, and then use counters to count through your lists and display them on the screen. Now, before we exit, let's try running this online and see what happens. So first, we're going to create a new experiment, and we will call this demo2 Stroop. And we will select our Stroop folder. And our files are pushing to Pavlovia and have been pushed successfully. So now we can click to run our experiment. And note that our new experiment has this warning. So we're going to go to the experimental page, just like we've done in the past. And we need to check that our files were uploaded and then switch our experiment into piloting mode. So I'm just going to view the code real quick and make sure I see both the JavaScript and the HTML versions of my experiment, which I do. And now I'm going to switch my experiment into piloting mode. And then we will try to pilot this. Now my experiment seems to have loaded well. I'm going to bring up the developer console. I did this in Chrome by holding Control Shift and pressing I. You can also do this by clicking into the drop-down menu, selecting Developer Tools, and then Developer Console. And the reason I bring up this console is this is where we're going to see those print statements that we printed out that showed us all the words and colors that we were loading. So when I click to start my experiment, I get an error. WordList.append is not a function. And this is your first introduction into the fact that some things that work in Python don't work in JavaScript. So wordList.append is a problem. Let's go back to our code and see what we can do to fix that. So going back into our code here, if we click into our stimulus loader and we look at our begin routine, we have this code wordList.append. Append is not a keyword in JavaScript. Push is the equivalent keyword. So JavaScript and Python just disagree on what that function should be called. And so rather than having Python automatically generate our JavaScript, we're actually going to switch this into both mode, and we're going to come in here, and we're going to change append to push. Also note that we have this rather complicated loop statement with pj_a and several checks and so on. This can be simplified a lot by simply saying for var I is equal to 0, I is less than 5, and then I plus equals 1. Or another way you could write that in JavaScript is plus plus. That's the same as plus equals. So, I mean, it's not a huge simplification of our for loop, but if you do much coding in Python, you will quickly see that the JavaScript equivalent loops and other things in that automatically get generated here can sometimes get quite complicated. And sometimes it's very easy to come in and simplify them, and it doesn't necessarily affect how your code's going to run, but it will affect readability when you come back later on and want to make changes. So changing append to push, simplifying our loop, that should be a good start. Let's save this. I'm going to sync this online, and notice that it detects that 3 files were changed. That would be the 2 JavaScript files and the 1 HTML file, so that is good. And then after this is synced up, I mean, I could have clicked the play, and that would have brought the experiment up in my browser. Because it's already open in another tab, once it's synced, I can just tab back to the screen and hit refresh, and this should bring my experiment back up. Note that because we're in piloting mode, every time you leave your experiment, you actually download your data file. So even though the experiment crashed before it even got to the opening screen, PsychoPy still downloaded my data file for me, which is handy. Now we're getting past the append error, but now we have another error. Shuffle is not defined. And this is where I mentioned to you guys that shuffle is not a default keyword you can use in JavaScript. Well, there's a simple fix for this too. We're going to go once again back into our stimulus loader code. And this time at the sort of very beginning of our code, before the experiment even begins, I'm going to define the function shuffle in JavaScript. And I'm going to make it equal to a function called util.shuffle, which is a shuffle function that exists in the online version of PsychoPy. So shuffle doesn't exist, but util.shuffle exists. And by making shuffle equal to this util.shuffle, I can now use shuffle the same way I would in the rest of the experiment. So by putting this at the beginning of the experiment, this basically unlocks shuffle for the rest of the experiment. And actually, this should be var space shuffle is equal to util.shuffle, not just shuffle. I'm once again going to sync online, 3 changes. That is correct. I'm going to let that sync, and then I'm going to go over to my web browser and refresh the page. And refreshing my experiment, I now see a new error message. So upper is not defined. The upper is the function that we were using to change words from our word list to uppercase. And once again, this is a specialized Python function. Upper doesn't exist in JavaScript, but let's find an equivalent. So this is occurring in our stimulus shuffler. And so we see our code was converting word list and color list to uppercase. We're going to have to switch this to both as well. And again, you can see, look at our loop, our for loop. How complicated it is. We can simplify this quite a bit by simply saying I is equal to 0, I is less than word length, word list.length, and then I plus plus. And so that's a much shorter version of the same loop. So when PsychoPy converts your Python loops into JavaScript, again, it does so accurately, but sometimes in a slightly complex way, and you can simplify things quite a bit. PsychoPy also likes to add extra parentheses around things, and you'll notice that in your JavaScript a lot. So we have double parentheses opening up this if statement. Just for, again, simplicity and readability, I'm going to get rid of the redundant opening parentheses. But upper doesn't exist, but to uppercase does. So very similar, just a different keyword. Rather than upper, it's to uppercase. And the rest is all fine. Now, if you wanted, you could come in here and you could add in the comments from the other side, and you could correct the spacing. Radar congruent, incongruent, list. I would recommend doing that. Again, it's nice to have your code to be as equivalent as possible on both sides so that you can just line the code up and see if you have more lines on one side than the other and where an error might be. I'm not going to for time. I'm not going to fill out all the extra comments here, but you can see once you switch to both mode, you can correct spacing and you can simplify some code here and there and do other fixes, aesthetic fixes like adding in comments and so on. Anyway, we're going to sync one more time, and I believe this might be our last error, but let us confirm that. Okay, we're refreshing our experiment page again. And, we left one more append in our code, which was for the congruency list. We didn't change that from append. So coming back into our stimulus shuffler code, we should have fixed this last time. So those needed to be changed to pushes. And now I think that's it. So refreshing our experiment now works. And once again, here's the same output that we saw printed out in our console, our Python console. Now, I know I'm kind of obscuring some of it. I can like lean out of the way so you can see it. But you know, you can take my word for it. It's the same output that we saw before. Here are the words we're going to see. Here's the colors. Here's the congruent or incongruent condition. So this is telling us the third item should be congruent. So if the third item is yellow, it should be in yellow, and indeed it is. And you can see how those all line up. Our experiment runs online identically as to how it runs in person. I'm pressing the R button right now to speed it through rather quickly, but I can also let it run and it will get to our end screen. Now, one last thing I just want to point out to you guys is that all these custom variables that we have been defining in our code are not actually getting stored in our data file. And so very quickly, I just want to show you how to store custom variables. We'll explore storing custom variables in the next few videos as well, especially our next advanced loops video. But right now, on every trial, a stimulus is being displayed, so word list current item, but that is not actually being logged in the data file. In order to log data into your data file, you can log any variable you'd like, but you need to use a function called add data. When you are writing it in Python, you can write it like so. So this experiment.addData, then you have the name of the variable that you want to log. So this will create a Stroop underscore name, or how about Stroop underscore word column in your data output sheet. And it will store on this trial the word that is being shown. We might also want the color. So Stroop color. We might want that to be logged, and this would be color list. The key that subjects press will be stored, but we might want the correct key stored. So the correct key was determined as the first letter of the current color. So that will get it in Python at least. And we might also want to know, let's say Stroop type. We might want to know whether the item was congruent or incongruent. So in order to actually log any of these variables to your data file, you need to use this experiment.addData. For the online version, for the JavaScript version, it's actually psychojs.experiment.addData. If you use this experiment.addData online, it won't work. We will explore logging data more in the subsequent videos, but I didn't want to leave this video incomplete. In case you just watched this video, you thought you were good to go, you try to run your experiment, and you can randomize your lists and display custom stimuli, but nothing's actually getting logged to your data file. So just as a caveat, any custom variable that you play around with, that you manually arrange for your stimuli, you also have to manually log that. And you do so using this experiment.addData. You come up with the name you want to appear as a column in your Excel sheet, and then you put the current value. And so this will log the Stroop word on every trial, the Stroop color on every trial, the correct key, and the congruent or incongruent status. So there you have it. This was our advanced look at how to load and shuffle lists, how to deal with list counters and randomization, how to convert things to make sure it's compatible to be running online, and how to fix those little online errors which are inevitable. They're invariably going to occur when you try and take a program that was written in Python and run it online. You can try and fix everything as best you can ahead of time, but invariably you're going to forget something, you're going to get an error, and you're going to have to know what the error is telling you and how to go and fix those in your code. So I hope this video was useful. If you haven't subscribed already to the channel, make sure you do so. And if you are in need of some PsychoPy help, I offer both consulting and programming services, the details of which are provided in the video description below. Don't hesitate to reach out if you need help. Thanks again for watching, and I'll catch you in the next one.